Good day, boys and girls. You are welcome to revisional lessons organized by foremost publisher, University Press PLC, for your forthcoming examinations you are preparing for, that is basic education certificate. We are going to look at some topics I informed you earlier that the series of lessons is organized by our foremost publisher. We only want to equip you and empower you such that during this period you will not waste any time and you are going to benefit in no small measure. My name is Akabi Sunday Olusegun, your presenter, and you are a member of Mathematical Association of Nigeria, the authors of all these books. We are all mathematicians. We know what you need to cover the syllabus for the examination you are preparing for. Thank you for listening, and I want you all to cooperate fully with yourself and with the sponsors. Thank you. We are going to start the lesson from where we normally start, even when you are in nursery school. The first in mathematics is numbers. We have small numbers, we have large numbers. But for our purpose, you are preparing for exam. Now, we have different types of numbers. We have the integers, the real numbers, rational and irrational numbers. But for this purpose, we want to start from what we call the decimal numbers, small and large, how to write them in expanded form, how to express them in significant figures, decimal places, even binary numbers, basic operation of binary numbers, and other bases. Thank you for listening. Numbers. Now, we are used to 1, 2, 3, 4. When it is written like this, say 1234. Boys and girls, is 1, 2, 3, 4 if the base is not specified. But because we are operating in base 10, that is why we are permitted or allowed to say 1234. What's the meaning of 1234? You have to know that this is the same thing as 1234. This 1234, that's 1230, is the same thing as 1234 if you put a bracket base 10. But we don't normally write this because we assume or believe. You can't go to the market and say 10 mangoes plus 15 mangoes is equal to 0 mangoes in base 6. No. But you count them in base 10. Now, we are going to let you know how to deal with large numbers. Large numbers. Even the ones that involve fraction. For example, if you have something like 767155 and they ask you to write it in words. Write in words. The first thing you need to do is to write it in expanded form. Now, we have the units, we have the tens, we have the hundred, we have the thousands, and we have 10 of thousands, 100 of thousand, 10 of thousand. Then 100 of thousand. If you look at all this, they are not for fun. They are not for fun. The unit, tens, hundreds, thousands, tens of thousands, and hundreds of thousands. What I'm saying is this: hundreds of thousands. The next one is tens of thousands, TTH. The next one is thousands, TH. The hundred, tens, and units. Now if you look at this, 767,000, it means 700,000 first, 767,155 is the same thing as 700,000 plus 60,000 now plus 7,000 then plus 100 plus 50 then plus 5. What is the meaning of this? Now 700,000, I say hundred of thousands. Ten of thousand, thousand, hundred, tens, units. Then 700,000, hundred of thousand, we have 7 under it. Now 10 of thousands, 60, 6 times 10, 60. 6 times 10, 60. 6 of thousands, then 7,000. Now under 100 we have 1. Under 10 we have 5 tens. Then under units we have 5. Now under 100 we have just only 1. 7,000. Now this is 60,000. 60. Why this one is 700. Now what I'm saying now is this: 700,000, 700,000 is the same thing as 7 multiplied by 10 raised to power 5. 60,000, 60, 1, 2, 3 is 6 multiplied by 10 raised to power 4. Now 7,000, 7,000 is 7 multiplied by 10 raised to power 3. Now 100, 100 is 1 multiplied by 10 raised to power 2. Now 5, 50 is the same thing as 5 multiplied by 10 or 10 raised to power 1. And 5 is the same thing as 5 multiplied by 10 raised to power 0, because any number raised to power 0 is 1. Now from here, because don't be frightened when you have to change from base 2 to base 5, from base 3 to base this, it is still the same thing you are taught right from primary school. What is the meaning of all this? 767155 76. Now going through this is nothing but 7 6 7 1 5 5 in bracket 10. We normally take this one as the beginning. Okay, we normally start from the first one here as the origin. This is 1 2 3 4 5. Everything is in base 10. The meaning is this is 7. I said this is origin. This one is 1. This one is 2. This one 3. This one 4. This one 5. What is the meaning? This is 7 multiplied by 10 raised to power 5. 0 1 2 3 4 5. So this is the same thing as 7 multiplied by 10 raised to power what? 5. That is why we have this. Then the second one is 6 times 10 raised to power 4 plus 6 multiplied by 10 raised to power 4 plus the next one 7 times 10 raised to power what? 3 plus 7 multiplied by 10 raised to power 3, then plus 1 multiplied by 10 raised to power 2 plus what again? 5 multiplied by 10 raised to power what? 1. Then plus 5 again multiplied by 10 raised to power 0. This is the knowledge carried to method of converting from base 2 to base 10. We are going to look at that later, but how to express large numbers in words is what we are examining. Now let me give you this example. Write in words. This is 1 2 3 4 5 6. Don't get confused. Look at these zeros. They are not useless. If care is not taken because the decimal point is not there, does not mean that you take 100 for thousands. If you remember, I said you are going to start from the unit, tens, 100, thousand, 10 of thousands, and 100 of thousands. Here it means this is 963,000. 900 and 63,000. You don't need to say it's 0 You don't need to say it's 0 tens and 1 and 1. 963,000 and 1. All these three figures, they are under thousand. For under 10, 100 is 0, 110 is 0. Not that they are useless. Now another one. Let's say you have to write in figures. 1,300,000 and 2,400. And 15. Now look at this. If care is not taking, you model it up. They say 1,000,000. You know the other time we start from units, 10, 100, 1,000, 10 of 1,000. Let me use small t now. 100 of 1,000. Now when you say 1,000 of 1,000, that is million. 1,000 of 1,000 is 1,000,000. Million. Then you go back to the question. 1,000,000. Then 302,000. Under 100,000 is 3. 302,000. 302,000. 302,000 because the 10,000 is not there. 302,000. Then 400. This is 3, 0, 0 and 2. Then tens of thousands. 302,000. Then 400 and 15. 1 in million. 300,000 because I want you to write the 300,000 plus 2,000. 2,000. 2 0 0 0. Then and 15 plus 10 plus 5. You know, for a million, 1,000,000 is 1,000 of 1,000, which is 1 0 0 0 0 0 0. 1 2 3 4 5 6. So in that case you have 1,302,415. 1 2 3 4 5 6. That is why you have 6 0 when you are writing a million. If you are writing 2 million, you have to write 2 and 6 zeros in front of it. Please take note. A million is 1,000. I will write it here. A million is 1,000 by 1,000. Now 1,000 by 1,000. You will think, why is it 1,000 of 1,000 and how is it written? 1,000 of 1,000. 1,000 is 1,000 by 1,000. that is multiplied by, that is the meaning of by. How many zeros now? That is 1, 2, 3, 4, 5, 6. That is a million. And by the time you get to standard notation, you say 1, 2, 3, 4, 5, 6. It is 10 by 10 by 10 by 10 by 10 by 10. And it's the same thing as 10 raised to power 6. Please take note. A million is 10 raised to power 6. A million is 10 raised to power 6. That is large number. Please take note. Now, what is the relationship between writing all this large number and base 2? Because that is where we are going. When you are talking of numbers, we are with decimal number. That is base 10. What is the relationship between this decimal number and binary number? Don't think that when you are to convert from binary number to decimal number, they are doing any magic. It is what we are used to right from primary school and the one you are used to right from junior secondary school. For example, if you remember the other time, I said 767 is the same thing as 700. Let's say you are now given 1011. You don't call this one 1011 when you are counting in base 2. This is not 1011, but you say 1011, you put a bracket, you say base 2. Remember, before I do this, I want you to link it with what you are introduced to when you are in primary 4. If you check mathematics for primary 4, primary 5, even for GSS 1, GSS 2, it is there. Expressing this number in expanded form. We are not doing anything. We are expressing this one in standard form as a powers of 2. But before I do this, let me start from simple. 7077, and you put a bracket, you put 10. This is 7077 base 10. In expanded form is the same thing as I said earlier. 7000 plus what is 0 is 0 what is 0 100, because there is no 100, plus 0 100 plus 70, then plus 7. What is the meaning of this? If you remember, Mom asked for GSS 1, page 3, 4, 5, 6. Go and check. They will tell you 7000 is 7 times 10 raised to power 3. Plus is 0 times, even if you like, you say 10 raised to power this. Is 0 times 10 raised to power what? Times 2. Plus 7 times 10 raised to power 1. Plus 7 times 10 raised to power 0. I don't want to do that now. Please look at my next number. I want to bring this one down, and I want it to look like this. This is 1011 in bracket base 2. You know this one is in base 10, and you know this is 3210. Now 7 times 10 raised to power 3 plus, you know, after this 7 we follow 077. That means we start from here, we call it origin. Then this one will be the first one, this one will be the second one, then the third one. Now what is the meaning of this? They are only saying expand, nothing more. This is 7 multiplied by 10 raised to power 3. That is this. Is 0 multiplied by 10 raised to power 2, and that is this, because this is 0. Then the first one, 7 multiplied by 10 raised to power 1, then 7 multiplied by 10 raised to power 0. Look at this now. That's what we mean. If you go by this, if this is our origin, we start from here, we start, this is second one, this is the third one. This one will be now 1 multiplied by 2 raised to power 3 plus 0 multiplied by 2 raised to power 2 plus 1 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. Compare. The only difference is when you evaluate this, what you are going to get is different from this one, because we are operating in base 2. The same thing, let's say you are given 2, 1, 5 and a bracket is inserted, they say base 3. They are only asking you to expand, and by the time you are expanding in this base, you are converting to base 10. You are converting to base 10. So this one, as usual, this is our origin, this is the first one. Don't say because what this is 1 is 1, this one, no, it's by coincidence. This is 2. Now this one now in expanded form will be 2 multiplied by 3 raised to power 2. 2 multiplied by 3 raised to power 2 plus 1 multiplied by 3 raised to power 1 plus 5 multiplied by 3 raised to power 0. Then you evaluate. By the time you get your value, that value, you don't need to put any base there again. You don't need to put any base. For example, this one will be 18 plus 3 plus 5, and this is 26. You don't need to put you don't need to put base 3, but this one is 26, while this one is 215. This one is not 215 but 215. They are not the same. Now that is on expansion. We call it expansion or convert to decimal scale. Now let's look at simple basic operation on different bases. Simple basic operations. Now let me start from the one you are used to when you are in primary school. If you are asked to add 299 plus 377, and you say 100 tens and you times, don't quarrel with me, say this is primary school, but I want to show you something. 299 377, when you say 9 plus 7, you say 16. The meaning in mathematics is this: 16. What is 16? 16 is 10 plus what? Plus 6. This 10, because you are operating in base 10, is just 110. It's just 110. So you write this one down. The 110, you carry it to this, it will be 10. 10 plus 7 will be 17, and 17 is the same thing as 10 plus what? 7. You write 7. You still carry this one, then this one becomes 6. The same thing in when you are dealing with different bases. For example, let's say you are to add all operation in base 6. Add 244, they put a bracket, not 244, because if you go for an interview, that is why if you are used to our textbook, you will be very funny. It will be very funny. They will never tell you this one is 244, because we are mathematicians. We are not historian. We will tell you it's 244. If they ask you what is this, I will say, and we put base there, and you tell us excuse me, it's 244 base 6. That's the end. You miss our interview. This is 244 base 6 plus 353 then base 6. In math, look at this one. That is why I wrote this simple one for you, so that by the time you are adding, you know that no, we are not performing mathemagic. We are not performing mathematics. 244 353, and then you are adding. Then we say 4 plus 3. That is where we are going. 4 plus 3 is 7. 7 is the same thing as 6 plus 1. Yes or no? You all know it is true. So you are going to write down 1, because that 6 is like the other one after getting 10. Then that 1 again, you say 1 plus 4. This is 5. 5 plus 5, 10. This 10 is the same thing as 6 plus 4. You write down what? 4. You carry 1. The 1 you carry is, you add to this. This is 3. 3 plus 3, 10. You don't write 10 down, because we are operating base 6. That your 6 is the same thing as what? Is the same thing as what? 6 plus what? Plus 0. You write 0, you carry 1, and you write that 1 here. So it becomes 1041, not 1041. I want to do the reverse process, so that you know that we are not performing magic. Students, you see I write 1041. If you leave your answer like this, we will give you 0, because we think you are telling us this is 1041. Put this one base what? You write 6, or if I were you, I'll put a bracket. You know that there are difference between 10. Look at how the number is written. You don't write 6 to be on the same line with this one, or else it will mean another thing. I want to do the reverse process. I want to take 353 from this one. You will discover that I will get this one if you cooperate with me. 1041, let's say the same. 1041 minus 244, and we say everything base what? Base 6. This is 1041 minus 244. You remember our 100 tens and units? You say this from this is not possible. Please, there is nothing like it's not possible in mathematics. It is possible. You go and borrow. You go and take from where there are more numbers. For this one, we want to take 4 from 1. 4 is more than 1. You have to borrow. But remember, we are operating in base 6. You take 1 from here. That 1 is 6. That one you pick from here is 6. 6 plus 1, 7. 7 minus 4, that's 3. You come here again to borrow. That one is 6. You know this one remains 3. 6 plus 3, 9. 9 minus 4, 5. This one has been taken. It remains 5, 3. So if you compare with the question, when we added this and this, we get this one. The operation is in base 6. Now let's go to simple basic operation of multiplying base 2. Because of our time, let's say we are asked multiply 101 by 11 base 2. They just write base 2. That is 101 multiplied by 11. 11 base 2. You say 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. There's no problem here. You get 1, 1, 1, 1. But the problem will arise. This is 1, 1, 1, 1 base 2. Then I want to, that is a multiplication. That's one operation. Then another operation is addition. You do it the same way we do base 6. The one that is very, very important is they will ask you to convert from base 2 to base 10, or from base 10 to base 2. That is why I will give you simple example, so that if you check all your past questions, the Becker exam, they normally give you very cheap questions. Let's convert 1001 base 2 to base 10. You know, I told you anytime you see that, they are only asking you expand. Expansion is required. What is expansion? They are 1001. You put a bracket 2. If you remember, this is 0, 1, 2, 3. That is 1 multiplied by 2 raised to power 3 plus 0 multiplied by 2 raised to power 2 plus 0 multiplied by 2 raised to power 1 plus 1 multiplied by 2 raised to power 0. This is 8 plus 0 plus 0 plus 1, and that is 9. Then you put a bracket. You put it 10, base 10, or you leave it as 9. The reason why I want to do this, they may ask you, convert this one to base 2. We want to change this one back to this one. Now, change 10 or 9, 9 base 10 to base 2. They may not use base 2, they may say change it to binary scale. Binary scale. The process is this. You draw a line and you start dividing. 9. You start dividing by 2 because it is in base 2. 9 divided by 2, the answer is 4. It remains 1. You use 2 again. 2 in 4, 2 remains 0. 2 again. 2 in 2, 1 remains 0. Then 2 again until you are tired. 2 in 1 is 0, remain 1. But we normally write it in this direction. This is 1, 0, 0, 1. 1, 0, 0, 1. Base 2. That is 9, base 10. Let me give you another one. This one is very common. I pick it is here. You know, it's very funny. I think NECO 2008, 2009, they are fond of asking you to convert either 89, 59, check to base 2. In fact, the one given 1 year was 39. So convert 39. They write 39, no base. That means in decimal scale. Convert to binary number. Convert to binary number. Change. In fact, I don't want to waste time. Change. They say change 39 to binary. They just write 39 to binary number. To binary. To binary. Binary means base 2. They only want you to do it like that. So you draw your line. Don't use calculator because you will get something point and it's not. It's 39. 2. You only need to write down the remainder. 2 in 39 You say 19 remain 1. 2 in 19. 9 remain what? 1. 2 in 9. 4 remain 0, 1. Then 2 in 4. 2 remain 0. 2 in 2. 1 remain 0. Now 2 in 1. 0 remain 1. Then you write in this direction. 1 0 0 1 1 1. Say therefore 39 base 10 if you like is the same thing as 1 0 0 1 1 1 base 2. Now finally, because the time is not our side, look at this simple one. I saw it OBJ Becker, I think 2012 2010. They say find x if 23 base x equals 1 1. The people are thinking that they want to, there's no problem, expand. This is your 0, this is your 1. You say okay, this is 2 multiplied by x raised to power 1 plus 3 multiplied by x raised to power 0 is equal to 11, because this is base 10. This one is 2x plus 3 is equals 11. From our knowledge of simple linear equations, 2x equals 8. Our x is equal to 4. That means it is 23 base 4 that is equal to 11. I thank you for listening, and I'm very sure the next lesson we are going to consider how to handle significant figures, standard notation, and other operation on numbers. Thank you for listening. We meet at the next lesson to consider further topics.